Elon Musk predicted that humans could set foot on Mars as early as within the next 10 years, while NASA aims to land humans on Mars by the 2040s. But what would life be like on the red planet? How can we adapt to stay alive? In this video on Daily Minute Science, we'll explore the challenges and possibilities of living on Mars and how humanity would adapt to living on Mars. Before we dive into this video, please consider liking this video and subscribing to this channel. This is completely free and it'll mean the world to me. You can always change your mind in the future. First, we need to know why Mars stands out as the most promising candidate for human colonization in our solar system. Mars is one of the few planets located in the habitable zone. Habitable zone is defined by NASA as the distance from a star at which liquid water could exist on the surfaces of orbiting planets. These zones are neither too hot nor too cold for life. Mars is also our closest planetary neighbor, with conditions that suggest the potential for sustaining life. It has polar ice caps and evidence of liquid water in the past. As we all know, water is essential for the survival of our species. The temperature on the red planet ranges from approximately -225 to 70 degrees Fahrenheit, or -153 to 20 degrees Celsius, with an average temperature of -80 degrees Fahrenheit, or -60 degrees Celsius. While cold, these temperatures are not extreme compared to other planets. Venus, the only planet other than Earth and Mars that is located in the habitable zone, has an average temperature of 870 degrees Fahrenheit, or 465 degrees Celsius. Furthermore, even though the pressure on Mars is much lower than Earth's, it is possible for humans to stay alive with proper technology. Fun fact, did you know Mars was once a habitable planet with conditions very similar to current-day Earth? NASA predicted that billions of years ago, when life emerged on Earth, the climate of Mars could have been Earth-like as well, with a thicker atmosphere than today and oceans of liquid water. There is a really real possibility that Mars had life in the past. Well, we are still on Earth, aren't we? There is a reason no one has ever stepped foot on Mars. Despite the intriguing possibility that Mars once had life, the journey to and survival on the red planet is easier said than done. One of the most significant challenges is the planet's thin atmosphere. The atmospheric pressure on the surface of Mars is less than 1% of the sea level here, or equivalent to an altitude of 45 kilometers on Earth. To put that into perspective, Mount Everest is only 8.9 kilometers, and it is already incredibly hard for hikers to breathe at that altitude without oxygen supplements. Furthermore, unlike Earth's atmosphere, which has 21% oxygen, Mars's atmosphere only contains 0.13% oxygen. This means that it is impossible for us to breathe normally on Mars. We will definitely need advanced life support systems to survive. Oh right, due to the low pressure on Mars, our blood and eyeballs will boil. With a significantly thinner atmosphere and no magnetic field, Mars has much more intense cosmic radiation than Earth. Radiation, to put it simply, is just waves or subatomic particles such as protons, neutrons, and beta particles that transmit energy. These energetic particles can be dangerous to humans because they pass right through our skin, releasing energy and damaging our cells and DNA along the way. Excessive radiation can ultimately lead to cancer or even death. Alright, now let's discuss how we can terraform Mars to make it like Earth so we can live there permanently. The two most critical challenges on Mars right now are the planet's thin atmosphere and extremely low oxygen levels. These problems are fundamental to making Mars largely inhabitable, which means solving these two problems could mitigate other problems as well. Strengthening the atmosphere not only stabilizes the temperature on Mars and makes it warmer, but it also protects us from harmful cosmic radiation. We all know oxygen is key to survival for most organisms, but oxygen is instrumental in various chemical reactions, such as combustion as well, which is the main method to generate energy. Ironically, when it comes to terraforming Mars, we could put our expertise in causing global warming to good use. By releasing greenhouse gases such as carbon dioxide and ammonia stored in the Martian polar ice caps and soil, we can thicken the atmosphere and create a greenhouse effect to trap heat and artificially warm the planet. It turns out, we might be pretty good at warming up a planet, this time on purpose. Increasing oxygen levels on Mars is another crucial step in making the planet habitable, and several approaches are being explored. Just recently, NASA's MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, has already shown promise by converting carbon dioxide from the Martian atmosphere into oxygen through solid oxide electrolysis, which could provide a steady oxygen supply. Additionally, we can introduce photosynthetic organisms, such as algae or cyanobacteria, which can harness sunlight to convert CO2 to oxygen, mimicking Earth's natural oxygen production. Lastly, when the ice caps on Mars are warm enough to melt and liquid water sources are identified, we can use water electrolysis, where water is split into hydrogen and oxygen using electricity. The hydrogen released can then be reused to generate energy again via combustion. However, with the current technological levels, terraforming Mars could take centuries, if not thousands of years. In the meantime, humans would need to adapt to the current Martian environment. Just as apes gradually evolved into humans through the process of natural selection, we might evolve into something entirely different on Mars. This process could be a true test of the survival of the fittest, where only those best adapted to the harsh Martian conditions would thrive. The planet's low gravity, high radiation levels, and thin atmosphere would create new pressures that could lead to significant changes in our physiology over multiple generations. We may develop larger lungs with increased capacity, thicker skins to protect us from stronger radiation, or even longer limbs suited to the low-gravity environment. Over time, we might resemble the very aliens depicted in science fiction. The Red Planet presents an incredible opportunity and a daunting challenge for humanity. As we look to the stars, we're not just dreaming about colonizing another planet, we're imagining the next step of human evolution. With innovation and adaptation, Mars could become our future home, pushing the boundaries of what it means to be human in the vastness of space. That's all for this video. Thank you for watching and staying to the end of the video. Have a nice day ahead.